In this video, we are going to discuss problem based on RC circuit. The question here says, an uncharged capacitor C equal 14.9 microfarad, a resistor R equals 24.3 kilo ohm, and a battery V equals 25.7 volt are connected in series as shown in the figure. What is the charge on the capacitor at t equals 0.3621 seconds after the switch is closed? So here you have an uncharged capacitor and we will write the value of C as 14.9 microfarad, which is 14.9 times 10 to the power negative 6 farad. And then we have a resistor R of 24.3 kilo ohm, which we can write as 24.3 times 10 to the power 3 ohm. And they are connected in series with a battery V of 25.7 volt. We need to find what will be the charge Q on the capacitor when time t is 0.3621 seconds after the switch is closed. Now when you close the switch, the capacitor begins charging. And you can find the charge at any given time using the expression Q equals Q max 1 minus e to the power negative t by tau, where Qmax is the maximum charge, which you can calculate as C times V EMF, and tau is the time constant, which you can find by multiplying R with C. So let's substitute this in the expression for Q. You get Q equals C V EMF 1 minus e to the power negative t over RC. Now let's substitute the values here to find Q. C is 14.9 times 10 to the power negative 6. V is 25.7. 1 minus e to the power negative t, which is 0.3621 over R into C. So R is 24.3 times 10 to the power 3 into C, which is 14.9 times 10 to the power negative 6. And when you solve this, you get the value of Q to be equal to 2.42 times 10 to the power negative 4 coulomb. So the answer will be option E. So this is how you can calculate the charge on a capacitor at any given time t when it is charging. Question 6.47. The circuit shown in the figure has a switch S. Two resistor R1 equals 1 ohm and R2 equals 2 ohm. A 12-volt battery and a capacitor C equals 20 microfarad. After the switch is closed, what will be the maximum charge on the capacitor? And how long after the switch has been closed will the capacitor have 50% of this maximum charge? So here in this circuit, you have two resistors R1 and R2 with values 1 ohm and 2 ohm respectively, connected to a 12-volt battery in series with a capacitor C of 20 microfarad. So you can write this 20 microfarad as 20 times 10 to the power negative 6 farad. In the first part of the question, we need to find what will be the maximum charge on capacitor. We know we can find maximum charge Q max by multiplying C into V EMF. So capacitance is 20 times 10 to the power negative 6. V EMF is 12 volt. That gives you the maximum charge to be equal to 2.4 times 10 to the power negative 4 coulomb. Or you can also write this as 240 microcoulomb. Next in the question, we need to find how long after the switch has been closed will the capacitor have 50% of this maximum charge. So for this, we are going to apply the rule for charge at any given instant in time for a capacitor. But before we do that, let us first find the equivalent resistance of R1 and R2. R1 and R2 are connected in series with each other. So I get their equivalent resistance as R1 plus R2. That will give me 1 plus 2, which is equal to 3 ohm. After finding the equivalent resistance, now I'm going to use the rule for charge on a capacitor at any given instant in time. We know that Q is equal to Q max 1 minus e to the power negative t over tau, where tau is time constant, which here in our expression will be given as R equivalent times C. We want Q to be 50% of maximum charge. That means it will be half of the maximum charge. So I can write Q as Q max over 2 because we want it to be 50% equals Q max 1 minus e to the power negative t over tau. Now cancel Q max from both sides. You are left with half equals 1 minus e to the power negative t over tau. Move this to the other side and bring the half over here. So you get e to the power negative t over tau equals 1 minus half, or e to the power negative t over tau equals half. Now I'm going to take natural log on both sides. So you take len e to the power negative t over tau equals len half. When you take natural log of e to the power negative t over tau, this negative t over tau will be multiplied on this side, and natural log of e will be 1. This will be equal to len half. Then I can find t by multiplying on both sides with negative tau. So we get t equals negative tau len half. Negative tau is nothing but minus r times c len half. Now let's substitute. T will be equal to R equivalent is 3 ohm. C is 20 microfarad, so 20 times 10 to the power negative 6 len of half. And when you solve this, you get T to be equal to 4.158 times 10 to the power negative 5 seconds, which you can also write as 4.16 times 10 to the power negative 5 seconds, or 41.6 microseconds. So this is the time it takes for capacitor to reach 50% of its maximum charge.